All right, today we are diving into one of the greatest scientific detective stories of all time. Seriously, it's a puzzle about the very ground we stand on, one that took brilliant minds centuries to piece together, and it completely changed how we see our world.
It all kicks off with something you've probably noticed yourself. Just look at a world map. See how the curve of South America seems to snuggle right into the coastline of Africa? For hundreds of years, people looked at that and thought, that's weird. Was it just a coincidence? Or was it a clue to something way, way bigger?
So to figure out why the surface of our planet is moving, we first have to understand what's going on deep inside. And that's a huge problem, right? I mean, the Earth's radius is more than 6,000 kilometers, and we've barely scratched the surface. So how on earth do we peek inside?
Well, our direct clues are pretty limited. The deepest mine we've ever dug only goes about 4 kilometers down, and our most ambitious drilling projects barely even get through the crust. But this is where we get clever. The indirect clues are amazing. By studying the seismic waves from earthquakes, how they travel, bend, and bounce through the planet, we can basically create an ultrasound of the Earth. It lets us see the layers inside without ever going there.
Okay, so with a rough idea of the Earth's interior, let's jump back to that puzzle. In 1912, a German meteorologist named Alfred Wegener looked at all these little clues and put forward this absolutely wild idea. One that, well, got him laughed out of the room for decades.
Wegener called his theory continental drift. He imagined that about 200 million years ago, all the continents we know were squished together into one giant supercontinent. He called it Pangaea, which means all Earth, and it was surrounded by one massive ocean. He argued that this supercontinent then shattered, and the pieces just, well, drifted apart to where they are today.
And he didn't just pull this out of thin air. He brought receipts. First up, Exhibit A, the jigsaw fit. And we're not just talking about a casual resemblance. Decades later, scientists with powerful computers confirmed it. If you look at the true edge of the continents, the underwater continental shelf, it's a near-perfect fit.
But it wasn't just the shape. Ancient rock formations 2 billion years old line up perfectly between Brazil and West Africa. And get this, fossils of a little freshwater reptile called Mesosaurus are found in only 2 places on Earth, South Africa and Brazil. How could a little freshwater creature possibly cross the entire Atlantic Ocean? Wegener's answer was simple. It didn't have to. The land was once connected.
He even had climate evidence. You find deep scratches in bedrock and deposits left by ancient glaciers in places like India and Africa, tropical places. That only makes sense if those continents were once huddled together way down south near the pole, covered in ice. The evidence was just staring everyone in the face.
But, and this was the killer question, what was moving them? When other scientists asked Wegener how continents could possibly plow through the solid ocean floor, he just didn't have a good answer. He guessed it might be the Earth's rotation or the tides, but physicists did the math and said, no way, not even close. So, because he was missing that one crucial piece, his amazing evidence was dismissed, and his whole theory was mostly forgotten.
Wegener's big idea just sat on the shelf for decades. But then, after World War II, new technology like sonar gave us the ability to finally map the last great unknown on Earth, the deep ocean floor. And what we found down there, well, it changed everything.
For the first time, we could see that earthquakes and volcanoes weren't just happening randomly. They formed these incredibly clear patterns, almost like seams stitching the planet together. There's a huge chain of them running right down the middle of the Atlantic, and another intense belt of activity all around the Pacific, what we call the Ring of Fire. These patterns weren't a coincidence. They were a huge clue.
And the discoveries just kept coming. They were stunning. The Atlantic floor wasn't a flat, boring plain. It had the world's longest mountain range, right down its center. And here's the mind blower. The rocks were brand new right at the top of that ridge, and they got older and older the farther away you went. The conclusion was unavoidable. New ocean floor was literally being born right there.
So in 1961, a geologist named Harry Hess put it all together. He called it seafloor spreading. He realized that these mid-ocean ridges were basically giant volcanic cracks where new crust was constantly being made, pushing the old crust out of the way. This was it. This was the engine. This was the force that Wegener had been missing all along.
Think of it like a giant conveyor belt. Hot magma from the mantle rises up at the mid-ocean ridge, cools into new rock, and pushes the older seafloor apart on both sides. And this incredibly powerful spreading action is what's actually moving the continents that are just sitting on top of it. This discovery kicked off a total revolution in geology. Scientists took Wegener's idea of continental drift, combined it with Hess's seafloor spreading, and created a single, powerful theory that explains just about everything that happens on our planet: plate tectonics.
And the fundamental idea is actually pretty simple. The Earth's hard outer shell isn't one solid piece. It's fractured into these massive interlocking slabs of rock we call tectonic plates.
Now, these plates are constantly on the move, sort of floating on the hotter, softer layer of the mantle beneath them. And this was the key insight that corrected Wegener's original idea. Continents don't just drift through the ocean on their own. Nope, they're just passengers, being carried along by the movement of these much, much larger plates.
And where these plates meet, that's where all the action is. Where they pull apart, we call those divergent boundaries, new crust is made, like in the Atlantic. Where they smash into each other, at convergent boundaries, mountains get built and crust gets destroyed. And where they just slide past each other at transform boundaries, you get massive earthquakes.
Okay, let's make this real. Let's look at one of the most dramatic stories in all of geology. The absolutely incredible journey of the Indian Plate and how it literally created the roof of the world.
So, about 140 million years ago, India was an island way down in the southern hemisphere. It broke off and started racing north at a pretty good clip, geologically speaking. Finally, around 40 or 50 million years ago, it slammed into Asia. Now, this was a collision in geological slow motion, but the impact was so unbelievably immense that it just crumpled the Earth's crust, forcing it up, up, up to create the Himalayan mountain range.
And here's the craziest part. It is still happening, right now. The Indian Plate is still ramming into the Eurasian Plate today. The Himalayas are still getting taller, year after year. The very ground beneath us is alive and constantly on the move. Which brings us to a final, pretty cool thought. The fastest plates are moving at about 15 centimeters a year. That's about the same speed your fingernails grow. It seems unbelievably slow, but over millions of years, it completely reshapes the planet. So where will our continents be in another 50 million years? What new oceans will open up? What new mountains will rise? The story of our dynamic Earth is definitely far from over.